Hey 7th grade, it is me, Mr. Connolly. And here I am doing a video again because I know it has been a little bit since I've uploaded these. It's just been kind of craziness going on lately, so I do apologize again for the lack of, seeing face-to-face videos. But moving forward, you should expect to see a little bit more than what I've been posting lately. Um, but just for today, what I want to do is rather than just like give you another assignment, there's no notes today. Yesterday you did notes. I just wanted to say if you are missing any work from this point going forward, please just shoot me an email or even send me a private comment, or not private, it's fine, on Google Classroom and just check in with me and see if you're missing anything. I will reach out to you later dates, but just for the vast number of middle schools I have to see, it's kind of hard to pinpoint every single one of you. So if you would just like send me a reminder, like, "Hey, am I missing anything? I'll get back to you right away, and I'll check it right away as well. All right. So what we've been talking about for the past couple days is the factors that affect the river's speed and basically the force of moving water and how moving water has been eroding our land for billions and millions of years and how it's created what we see today. And we talk about rivers, we talk about river features such as oxbow lakes, we talked about meanders. All right, so now we're going to be talking about the factors that affect a river's speed. All right, so to start things off, I'm going to read the little intro right here. All right, it says the table below contains data gathered from an experiment that used a model of a stream in the laboratory. The stream model could vary in angle of slope and in volume of flow. For each of four different angles of slope, scientists measured the stream speed at a low volume of flow and at a high volume of flow. So when I talk about the stream gathered from an experiment, use a model of a stream in the laboratory, if we were in school, what we would have done is something very, very similar. That's me right there. Very, very similar to this video. All right, so this is mimicking what the laboratory would have looked like. All right, so here is our sediment. All right, in this case, it's clay-sized particles, it's sand, there's some rocks and some little mini boulders and pebbles. So what you're going to see in the video is that the science is going to create this meander down here. Right, it's going to empty out into an ocean. All right, going. All right. So as we let water flow, you're going to see how the water starts to erode the land. All right. And what's happening is that this table that the sediment and the water is on, all right, it's called a stream table. And we talk about, well, right, here's a little close up of what's happening. Watch this. It gets eroded away. There's erosion right there. It's going to be carried down. So when we talk about a stream table, all right, we're talking about the table or the stream tray that the sediment is inside of. All right, and we can change the angle. So here's a flat. Here's 5-degree increase of slope, 10 degrees, 15, and then 20. Okay, so we're talking about the angle at which the topography starts to change. As we increase the angle, right, we're also increasing the slope. So at 5 degree, the volume of flow is low, which means that we let out a little bit of water. We do the same thing again at 5 degrees, all right, but now we release a larger amount of water per second. All right, that's what we mean by low flow and high flow. All right, so you see the angle of slope here, 5 degrees, 10, 15, and 20 at low and high speeds, or high and low flow. And then you get to see how the speed, all right, changes based on slope and based on the volume of flow letting the water pass at, and you see a stream speed in centimeters per second. All right, so for example, at 5 degrees, you get to see at a low flow, 43.5 centimeters of water are passing through per second. Okay, so what you're going to do next after using this table, you're going to answer the following questions. When the angle of the slope is 10 degrees and the volume of flow is high, what is the speed of the stream? So let's look. When the angle is 10 degrees and the volume of flow is high, What is the speed? It's that simple. Okay? Same thing for number 2. When the angle of the slope is 20 degrees and the volume of the flow is high, what is the speed of the stream? You're just going to use the table again for that. Okay? Let's see. I don't know how I can end this video. Is this still recording? It is recording still. Sorry about that. Okay? So, what you're going to do next. Sorry, I couldn't see myself on the screen. I thought I stopped recording. So, number 3. What is the relationship between the angle of slope and the speed of the stream? 4. When the angle of the slope is 5 degrees, how does increasing the volume of flow affect the stream's speed? So, here we are. You go up, 5 degrees. Low, here's your speed. 5. High, here's your speed. So what happens when we change the flow from low to high? Okay, you let me know. All right, and then for number 5, when the angle of the slope is 15 degrees, how does increasing the volume of flow affect the stream speed? Number 6, what is the relationship between the volume of flow and the speed of the stream? And then 7, this is kind of like a prediction, like a hypothesis. When a river floods, would its water flow faster or slower than its normal speed? Okay, so as you've seen, based on the relationship number 6, as you've seen, as we increase the flow of water from low to high, you should see what starts to happen between the speed. But what if we make this extra high and we have a flood? All right, what's going to happen to your speed? All right, that's all it's asking. All right, so if you would like to watch this video, you can rewind it, you can pause it at points. I'm just putting this video up there because I said I would start to make more videos. And sometimes when you hear it from the perspective of, like your teacher, like myself, it kind of just makes more sense that way. All right, so this is going to be your assignment for today. All right, today is Friday, and this has no due date, but what I would recommend highly is, I know it's Friday. I think this is kind of an easier assignment that you would have. When you finish this assignment, maybe just go back to your work for science, see if you're missing anything. If you want to ask me if you're missing anything, please reach out. But I just think that would be a good way to kind of keep yourself leveled and to not create any extra stress for yourself when, there's a week left of school and you're like, oh, what did I miss? And I tell you missed all these assignments because you forgot about them. But that's just what you're going to be doing for today, and that's just my recommendation for you guys to be doing with this time off. All right, so this is your assignment for today. If you have any questions, please let me know, and I hope you guys have a great weekend. If you guys are doing anything really special, as long as you're socially being distant and being safe and healthy, please, comment, and I'll get back to you. And that's really much it. All right, so I hope you guys have a great weekend, and I hope to see you guys soon, and I hope you guys are just doing well. All right, so take care, and I will talk to you guys soon.